lesson 7.5, factoring trinomials of the form x squared plus bx plus c, you should be on page 386. In this lesson, you will learn how to factor a trinomial with a lead coefficient of 1. So remember, trinomial means three terms. Let me write them down. You have 1, 2, 3 terms. There's a trinomial. I'm going to learn how to factor those when the lead coefficient, the number in front, is 1. You will also learn how to use this factoring to solve real-life problems. So let's talk about factoring trinomials. When a polynomial is written as a product of factors, that's called factoring. Okay, remember, product is multiplication. So in other words, this is saying what we're looking to do today is take this trinomial and write it as a multiplication of two binomials. I think when we show you some examples, that will make sense what we're talking about. So we want to change a trinomial into, they show it as two binomials multiplied together. Let's talk about how do you factor a trinomial. Now you notice the lead coefficient right now is a 1. Okay? How would you factor this? So it's in 3 easy steps. First, you have to think about what factors multiply out to c. So what times what would give me c? And then the next step, those same factors, when you add them together, have to add up to b. And then you write the binomials using those factors. So if you're like, I don't get it, okay, it's simple. Take, for example, this. This is a trinomial. The lead coefficient's 1. So let me just write a couple notes off to the side. Right now, c is 8 and b is 6. So let's go to step 1. What multiplies out to 8? Well, let me think. 1 times 8, 2 times 4. Okay? Those same factors must add up to b. b is 6. Well, do 1 plus 8 add up to 6? Nope. What about 2 plus 4? Yes, it does. So write the binomials using these factors. So the answer to this would be x plus 4 times x plus 2. Now, this is the correct factoring for this trinomial. If you don't believe that, or you're like, I'm not getting it, well, watch. If I double distribute, I'll get right back to here. Watch me double distribute. X times x is x squared. X times 2 is 2x. 4 times x is 4x. And 4 times 2 is 8. And I have x squared. Those add up to 6x plus 8. So do you notice I'm getting right back to where I started? So that's the correct factoring for that trinomial. So it's easy. It's 3 steps. It's these 3 steps. Think about what multiplies out to c. Those factors must add up to b, and then write out your binomials using those factors. Should be easy to do. Now, there's a couple quick things, and we're going to practice some. When c is positive, your factors must have the same sign as b. So let's go back. So if this number is positive, then I look over here. You see how that's positive? That means both my factors have to be positive. That's what this statement is telling me. Now, if c is negative, that means that my factors would have different signs. Okay? So we'll look at some examples of that in a minute. And as we go through them, I think you'll see what they're saying here. Let's try factoring x squared plus 10x plus 16. So right now c is 16 and b is 10. Do you notice how b is a positive? C is positive and b is positive. That means my factors have to be positive amounts. So let's think about my factors. What would multiply out to 16? Well, 1 times 16 multiplies out to 16. So does 2 times 8. So does 4 times 4. Okay, let's see which of these add up to 10. 1 plus 16 isn't 10. Oh, 2 plus 8 would give me 10. 4 plus 4 is not 10. So there's my factors, 2 and 8. So the correct factoring for this would be x plus 2, x plus 8. That is the correct factoring for this sample, and you can see that here. Okay? What I would like you to do is pause the video. Why don't you try factoring these two polynomials? I'm back. You should be getting these two answers for factoring the two trinomials that you see here. If you have questions, make sure you ask in class time. Okay, now what happens if I have a positive value for C, and you can see that in this example, positive value for C. If I can get this to turn on, there we go. But B is negative. Okay, so if that happens, that means both of my factors have to be negative amounts. So C is 12, B is negative 8. So I got to figure out what times what is 12 but adds up to negative 8. Well, negative 1 times negative 12 is 12. Negative 2 times negative 6 would give me 12, and negative 3 times negative 4 would give me 12. Which of these combinations add up to negative 8? Well, it's not that. Those don't add up to, it's right here. Those two add up to negative 8. So my correct factoring would be x minus 2 times x minus 6, and you can see that here. So if C is positive but B is negative, both of my factors have to be negative. That's what this little statement's telling me. Now, what happens if my C value is negative? That means my factors will have different signs. Maybe I should highlight that. I have different signs when that happens. So let's try that down here. I have a sample where C is negative 21 and B is 4. So my factors must have different signs. So I could have, let me see, 1 times 21 is 21. So I could have negative 1 or negative 21. I'm just going to put plus minus plus minus. 3 times 7 is 21. Okay, plus minus plus minus. Okay, so let's try. Would negative 1 and 21 add up to 4? Nope. What about 1 and negative 21? Well, that doesn't add up to 4 either. What about 3 and negative 7? Oh, we're getting closer. Those two add up to negative 4, but I want positive 4. Negative 3 and 7 add up to 4, and they also multiply up to negative 21. So there's my factors. So my correct factoring must be x minus 3, x plus 7. So if C is negative, but B is positive, then I know my factors must have different signs. And that's what's happening here. Okay? What I would like you to do is pause the video and try these 8 questions. And we're back, and I put the answers to these questions up here. And again, if you're not getting these to factor right, make sure you ask in class. Here's the key thing to remember. I'm going to go back a few slides to do the questions I just asked you to do. It's these 3 steps. What multiplies out to C? Those same 2 numbers have to add up to B, and then just use those numbers to write binomials. It's as simple as that. And to wrap up the video, we can use factoring to solve real-life problems. So in this question, a farmer plants a rectangular pumpkin patch in the northeast corner of a square plot of land, and you can see that here. There's the pumpkin patch. The area of the patch is 600 square meters. What is the area of the square plot of land? So we're going to have to write an equation and solve this. You're given the area of the pumpkin patch, the difference of the side length of the square plot and the length of the pumpkin patch, and the difference of the side length of the square plot and the width. Okay, so they're just saying that they labeled this for you. Okay? So I think it's fair to say that the length times the width of this patch is 600. Okay, so, but I don't have that label here, but this is what I could say. If you notice here, this length would have to equal S minus 40. So let me highlight that. All the way across is S, and from here to here is 40. So L should equal S minus 40. So let me write that down. This is S minus 40 for L. And the width, in the same way, if I highlight, okay, from here to here is S units, but from here to here is 30, so the width would have to be S minus the 30. So we all know that to find the area of a rectangle, length times width would equal the area, which is 600. Now the length is S minus 40, and the width is S minus 30, and that should equal 600. Okay? And you notice that's what they have here. Okay, now I want to solve this. So to solve it, the first thing I'm going to have to do is double distribute. So let's do that. Double distributing. S squared minus 30S minus 40S plus 1200 equals 600. Okay, let's simplify. S squared minus 70S, I can combine those together, plus 1200 equals 600. Now to solve this, it's a second degree. I got to factor this. So let's get everything on one side, 0 on the other. Okay. And I have S squared minus 70S plus 600 equals 0. Now, this is a trinomial with a lead coefficient of 1, which means I can use my 3 rules now. So all I got to think about is what times what is 600 and adds up to negative 70. Okay? That's pretty easy because it's got to be negatives. Think, isn't negative 60 times negative 10 positive 600? And isn't negative 60 plus negative 10 negative 70? I think we just found our factors. It's negative 60 and negative 10. So let me write my equation out. It's x minus 60, x minus 10 equals 0. That means to solve, I can use the zero product property. One of these have to equal 0. To make this equal to 0, x would have to be 60. And to make this equal to 0, x would have to be 10. They used S. Oop, I should put S in there. So this, I should use S instead of x. So S could be 60, S could be 10. Now, I have to think, are these both reasonable? Okay? Are these answers reasonable? Let's try it. If I put a 60 in for S, 60 minus 40, the length could be 20, 60 minus 30. It could be length 20 and width 30. Let's try 10. 10 minus 40 gives me negative amounts, so that doesn't make any sense. So I know right now the side length had to be 60, okay? So if the side length is 60, now we got to answer the question, what's the area of the square plot of land? It's 60 times 60. The area would be 3,600 square meters, okay? I'm going to pause the video here. If you have questions, make sure you ask in class.